Hello, my name is Sweidan.
And my name is Badar Zaman, and we are from Qatar Science Technology Secondary School for Boys.
I will start with the research problem. Our research problem was that the soil in Qatar is not suitable for plants. Adding on to that is the temperature and humidity here, which makes it almost impossible for plants to survive in this country, as well as the lack of care in agriculture in Qatar. And what applies in Qatar applies to other countries. So our solution idea was to make a robot that depends on three things, which is the artificial intelligence from the image processing, as you can see from this camera, the Internet of Things, which as you can see from the multiple different sensors and different components which work together to make to do their job, as well as the sustainable energy, which is a good choice because of the fact that it can charge while it's doing its work in a garden or in an open space. Now I will talk about the special stuffs about this robot, and I will start off first with the NPK sensor here. As you can see, NPK stands for nitrogen, potassium and phosphorus, and this sensor does something which is very helpful for this robot, which is it measures the level of nitrogen in the soil as well as phosphorus and potassium. It also checks the soil moisture levels, which can help the robot determine whether the soil needs nutrients or not. And with the artificial intelligence here, the camera, it depends on a QR code such as this. And in real life application, if this robot was in a garden, you'd place these QR codes around for each plant, and when the robot sees them, it will keep on going until it leaves a distance of at least 10 centimeters between the robot and the plant, and then it will use its NPK sensor to find out about the robot. As you can see here, this is a video of a real-life application of a robot outside in a garden.
So for this project we used a lot of designs, but this was our best design. As you can see, we used these huge tires because we wanted our robot to drive in any terrain. So we thought that the big tires and the big wheels is the best choice for us.
Now I will show you a real-life demonstration of how this robot works. As you can see here, this tablet will show you a live stream of the camera. As you can see here, I'm currently waving my hand. Now I will present the robot with the QR code, and you'll see what happens after I present it. So first of all, the robot will see the QR code. It will tell you at what distance, the distance between the robot and the QR code. After a bit, it will start moving, and it will keep on moving until it gets closer and closer to the QR code. And now what will happen is the NPK sensor will dig into the soil and measure the plant level. And as it is checking here, it will determine whether the soil is missing nutrients or not. Now, after it will come out, it will know that this soil is missing nutrient levels. And because it is missing nutrient levels, it will spray water and nitrogen, as you will see. And as you can see here, it sprayed it. And as you will see, it will go back and then go look around for another plant. Here are the water tanks. Not just a water tank, to be exact. Frankly, it is a water tank, a nitrogen tank, potassium, and phosphorus. Now each tank has its own special needs, whereas the water tank will need water, the nitrogen tank will need nitrogen, phosphorus will need phosphorus, and potassium will need potassium. And here are the sensors. As you can see, this is the humidity sensor and this is the temperature sensor. And when they are working together, they are considered an Internet of Things, like I said.
So as you can see, as my friend mentioned about the demonstration, so this is our mobile application app, and as you can see, it tells us about the logistic sensor data. For example, the air quality sensor, the humidity sensor, and the temperature sensor. It also tells us about the soil nutrition tank level. For example, the water tank level, the nitrogen tank level, the phosphorus tank level, and the potassium. And it also tells us about the soil nitrogen NPK sensor data, and the soil phosphorus, and soil potassium, and the soil moisture, if it's dry or not. When the camera goes to the QR code, the device tells us about the type of tree and tells us a short definition of the tree, as you can see here.
As you can see, the robot detected a fig tree, as you can see from the QR code, and we used figs because they are one of the most difficult plants to grow in Qatar because of the temperature and the lack of moisture in the soil.
So as you can see, we compared our robot with the Nexus robot, as you can see here. But the problem was that the Nexus robot cost approximately like $13,000, while our robot costed $327. And also our robot has additional features that the Nexus robot doesn't have.
And this additional feature that my friend was talking about is that this robot can give the soil the missing nutrients. Now, using the high-end artificial intelligence to process images as well as the IoT for all these sensors and devices to work together in harmony, I think that this device is a revolutionary idea that will help change agriculture industry as a whole and add even more to it. On top of that, I think it will help improve countries to depend more on themselves for agriculture as a whole. Thank you for listening. My name was Sweidan.
My name is Sweidan, and we hope you liked our project, and thank you.